You see, performing operations with decimal numbers is quite straightforward, and the reason is because we are used to performing operations with decimal numbers. For example, if I say add 19 plus 12, this will be very easy because this is going to be 9 plus 2 will be 11. Then you take 1 to the next number here. This will be 1 plus 1 plus 1. This will be 3. So you say, okay, the final answer is 3. And you notice something interesting here. Because we're adding numbers in base 10, you would say, okay, this is 9 plus 2 is 11. So you don't just write the 11 down because the 11 is greater than the base we are working with. So you just write 1, then carry the other 1 to the other side. So anytime you're working a particular base, you don't write your final answer. If your final answer is greater than that particular base, you don't write that as your final answer. You try to write a number that is lower than the base you are working with, and that's how it works with all the bases. So let's say we have these numbers in binary. We have these binary numbers as base 2 numbers. I want to add these binary numbers. One important thing we need to take note of before we start adding is, let's say you have 1 plus 0 in binary. 1 plus 0 is 1. 0 plus 1 is 1. But what if we have, now you see we're writing 1 1. These numbers are in base 2, and you notice that 1 is less than 2. So let's say we have 1 plus 1 and we have to add this in base 2. Now 1 plus 1 in base 2 can never be equal to 2. This is because 2 is equal to the base. 2 is equal to the base. So anytime you are adding or performing operations in a particular base, and you add or you subtract, you multiply, you divide, and you get a result that is equal to the base or greater than the base, you don't write that number as your result. What you do is you try to, like for example here we added 1 plus 1 and that gave us 2. So you just say, okay, since it's giving us 2, we can't write 2 there. Now you say, since we are working in base 2, we are adding this in base 2, you say, okay, what number can I multiply with the base 2? You know we are working in base 2, so what number can I multiply with the base 2 to give me 2 here? So you say, okay, this is the base 2. What number can I multiply with the base 2 to give me 2 as my final result? So the only number we can multiply with 2 to give us 2 is 1. So 2 times 1 here will give us 2. Then you'll always write a remainder. Now since 2 times 1 gives us 2, the remainder here will definitely be 0. So 2 times 1 gives us 2, so there is no remainder. So just write 0 as well. You should always write a remainder like this. So this will be 2 times 1 remainder 0. So it means you write the remainder, which is 0, as your answer here. Then carry this one here to the other side, and you have 1 here like this. So let's say we have 2 plus 1 and we are asked to add this in base 2. What you just do is 2 plus 1 is going to be 3. 3 is greater than 2. So what we'll do here is we'll say, okay, take your 3, bring your 3 here. Now you now say, okay, what number can I multiply with the base 2? You know we're adding in base 2. So what number can I multiply with base 2 to give me 3? Now 2 times 1 is 2. 2 times 2 is 4. So if we say 2 times 1 is 2, if we try 2 times 2, 2 times 2 is 4. 4 is greater than 3. So let's just stick with 1. 2 times 1 gives us 2. Remainder 1. You know, if we get 2 times 1, 2, we have to add 1 to 2 to give us 3. So we have a remainder of 1. So you just take this remainder, write the remainder here, 1. Then you know we have 1 here again. So you just write this 1. Carry this 1 to the other side. So you have 1 here like that. Now with this idea, we can try to add these questions here. So let me just clean this. We'll use this same idea to add this up. So let's come here. So we say 1 plus 1 here is going to give us 2. And since we're working in base 2, we can't write 2. So what we'll just do there is we'll just say 2 is, now what number can I multiply with the base 2 to give me 2? So we can multiply the base 2 by 1, and that will give me 2. So since we have no remainder, I'll just write remainder 0. So write the remainder 0 here. Then carry this 1 here to the other side. So I'll just carry it to the other side. That's our 1. So 1 plus 1 is also 2. So we can write down 2 there. So you still do something like this. But since we have this, there's no need to write it again. 2 times 1, we multiply the base by 1. That will give us 2. Then remainder 0. So you write down 0. Carry this 1 again to the other side. This is 1 plus 1, which is 2, which is still the same thing. Okay, if I have 2, which is still the same thing, what number can I multiply with the base 2 to give me 2? That's 1, then remainder 0, remainder nothing. So I write down 0, carry 1 to the other side. So 1 plus 1 plus 1 is 3. So I write 3 here. Now for this 3 here, we'll say, okay, for the base 2, what number can I multiply with the base 2 to give me 3? There's no number like that. So we'll just say, okay, if we multiply 2 by 2, that will give us 4, and we don't want 4. So we'll just say 2 times 1 will give us 2. Then remainder 1. We still have 1 left. So that will remainder 1. You just write it here. Then you notice we still have 1 here. This 1, you'll take it to the other side. So you write it here like this. This is our final result. 1 1 0 0 0 in base 2. That's our final result there. So we'll go to the next one. Now for this one here, we're asked to add these binary numbers here. Now you notice this point, you see this is 101.011, 11.1101, 1.101. Now these points here are not called decimal points, they are called binary points. Binary points, because the numbers are binary numbers. So what we'll do is we'll try to arrange these binary numbers according to the binary points. Now what I mean is, for the first one, this is 101.011. The next one is, now you notice the point is here. This is the binary point there, so I'll just put the point here. So that will be 111101. Now that's very important. Arranging your numbers according to the binary points is very, very important. Now the next one, the point will be here. So you just write 1, then 101. This arrangement is very, very important. So we'll just add up, or add this up. So this is going to be, so in this empty spaces you can just put 0 0, then 0 0, then 0. So 0 plus 1 plus 0 gives us 1. 1 plus 1 here gives us 2. Now the question is, we can't write 2 here. The question is, okay, if we have 2 here like this, what number can we multiply with the base 2? Since we're working in base 2, what number can we multiply with base 2 to give us 2? That's just 1. Then there's no remainder, so you just write remainder 0. So this remainder here, you write it here 0. Then carry this 1 to the other side. So you carry 1 here. So you say 1 plus 1 plus 1 gives us 3. So you write down 3. So you say, okay, what number can I multiply with the base 2 to give me 3? There's no number like that. So you just say 2 times 1 will give us 2. Then remainder 1. So I'll just write 1 here. That's this 1. You write it down. Then carry this other 1 to the other side. So you have 1 here. So 1 plus 1 plus 1 gives us 3. Like this same 3 here. So what you just do is you write down 1 again, which is the remainder. Write 1 here, then carry this 1 to the other side. So we'll have 1 here. And this is 4. So you add 1 plus 1 plus 1 plus 1 gives us 4. So we'll say, oh, okay, this is 4. So what number can I multiply with the base 2 to give us 4? And that will be 2 times 2 will give us 4. 2 times 2 will give us 4. Remainder 0. There's no remainder again. So write down the remainder, which is 0. Then carry 2 to the other side. So this is 2. So you add 2 plus 1, which is 3. And we've already done that here. 2 plus 1 is 3. So it will be, what number can I multiply with the base 2 to give us 3? So this is 2 times 1 is 2, the remainder 1. So you write down the remainder, which is 1. Then carry this 1 to the other side. So I'll just bring the 1 here, which is 1 plus 1 gives us 2. So we have the 2 here. So we'll just say, oh, okay, what number can I multiply with the base 2 to give me 2? That's 1. So you say 2 times 1 will give me 2, remainder 0. So write down the remainder, which is 0, and carry 1 to the other side. We'll carry 1 to the other side. So this 1 here, just take it to the other side. So you have 1 here. So this is our final result. I'll just put my binary point here like this. So this is, when you add this and this and this together, this is the result in base 2. Okay, let's go to the next one here. For these numbers here, we have to add this together. So this is 1 plus 1 plus 1, which is 3. We can't write down 3 because we're working in base 2. So we'll just say, okay, since we're working in base 2, say, okay, 3. What number can I multiply with the base 2 to give me 3? There's no number like that, but the closest is to 1. We can't say 2 times 2. 2 times 2 is 4. 4 is greater than 3. So we'll say 2 times 1, then remainder 1. So write down the remainder. Carry 1 to the other side. So this is 2. 1 plus 1 gives us 2. We can't write down 2, you know now. So this would be 2 is equal to 2 times 1. That's what number can we multiply with the base to give us 2, which is 1, so 2 times 1 gives us 2, then remainder 0. So you write down the remainder, which is 0, then carry this 1 to the other side. So take 1 to the other side. We have 1 plus 1 plus 1 gives us 3, and we've done that here. So just say, okay, the remainder here is 1. Write down 1, then carry this 1 to the other side. So we'll just take it to the other side again. It's still 3 again. 1 plus 1 plus 1 gives us 3. So it's still 3 here, and we've done that. So we'll just write down the remainder, which is 1, and carry this 1 to the other side. So just take it to the other side here, and this is going to be 1. So it means that the final result here is 11101 in base 2. So these are our results.